Okay, so this video just recaps on some algebra functions. So the function hx gives the approximate height of the water at Hoth Harbour on a particular day. Now, remember that fx or hx or gx, they all effectively just mean y. Okay, so hx, y, is equal to 10x squared minus 50x plus 30, where h is the height of the water in centimetres and x is the time in hours after 12 noon. Okay, so I want to draw the graph between 0 and 5. So the first thing we need is our table of values. So I've got x and y, and in the middle I've got my function that I'm using. So 10x squared minus 50 x plus 130. And then I've got 0, 1, 2, 3, 4, and 5. Okay, so I'll have 10 times 0 squared minus 50 times 0 plus 130. 10 times 0 is 0, 50 times 0 is 0. That leaves me with 130. Okay, so I have the couple 0, 130. The next one, I sub in 1. Minus 50 times 1 plus 130. And you can sub this in exactly as is onto your calculator. So I'll have 10 bracket 1 bracket squared minus 50 bracket 1 plus 130. Okay, and for this one you'll get 90. Okay, so I'll have 1, 90, then you'll have 2 squared minus 50. Okay, so I'm subbing in for x every time the different values down the side. Okay, now remember your indices come first. So this would be 10 times 4. Okay, so 40 minus 50 times 2, which is 100, plus 130 is 70. Or you can stick it into your calculator exactly as it is with the brackets. 10 times 3 squared minus 50 times 3 plus 130. And you'll have 3 squared is 9. 10 times 9 is 90. Minus 50 times 3 is 150. Plus 130. And that will give me 70. 10 by 4 squared minus 50 times 4 plus 130. Okay, what you will find is that your graph starts to repeat. Okay, so 4 squared is 16. 16 times 10 is 160. 50 times 4 is 200 plus 130. So you'll actually start to see that your values have started to go from 130 down, and now they're starting to come back up. Okay, and then you'll have 10, 5 squared minus 50 by 5 plus 130. Okay, 10 times 25 is 250 minus 50 times 5 is 250 plus 130. Okay, so we have these points now to plot. Okay, and getting these right is very important. I know that it has to be a curve, okay, because it's got an x squared, so it has to be a curve. So 0, 130 is up here. 1, 1, 1 and 90 is here. 2 and 70, 3 and 70, 4 and 90, 5 and 130. So I get this graph. Now it's a curve, so it keeps curving down. Okay, what I don't want to see is flat lines here. Okay, there should never be flat lines there. It's a curve. Okay, then I have the questions. Use your graph to find the height of the water at 12 noon. Okay, so x is the time after 12 noon. So at 0, that must be 12 noon. Okay, so if I go to 0, I'll use a different color here for these. 0 all the way up, that's 130. The height of the water at 12 noon is 130. At its lowest point, so the lowest point you're talking here. Okay, bringing it in. Okay, so somewhere there between 65 and I suppose 68. 68. Okay, because that would be however you drew your graph. So mine there, the curve comes right down. It looks like it's exactly halfway, so 65. Somebody else's might be a little bit further up and might go for 67 or 68. Okay, that little curly sign there means approximate. After 12 noon, how long did it take before the water was at its lowest point? Well, these graphs are symmetrical. So exactly halfway down the graph is here. So 1 hour, 2 hour and a half. So 2 hours, 30 minutes. Okay, or I could have said 2.5 hours. Right, this one's a little bit more tricky. Okay, this one we're given a graph, and sometimes when we're given the graph, it is the harder one. Gx is equal to ax squared plus bx plus c. Find the value of c. Well, c is the y-intercept. So let's look at my graph. Okay, and where it intercepts the y-axis, c is equal to 180. Could have also said that at this point, it's 0, 180, and subbed in my values for x and for y. Remember, gx is y is equal to ax squared plus bx plus c. So 180 is equal to a times 0 plus b times 0 plus c. Anything multiplied by 0 is 0. 180 is equal to c. Okay, but we could get it straight away by looking at the graph either. Okay, now I've used the point 0 and 180, but I have two other points. Okay, remember I said these graphs are symmetrical. So this point here must be 3, because 0, 3, 6. And this point up here is 6 and 180. Okay, and this is here is 3, 0, because it's on the x-axis. So I know that c is equal to 360 now. So I have y is equal to ax squared plus bx plus 180. So I know what c is. And let's take the points 3, 0 and 6, 180. Okay, and I know that 3 is my x coordinate and 0 is my y. 6 is my x, 180 is my y. So if I sub 0 in for y and 3 in for x, and then in the second one, so I use 2 points separately. So this point is for this graph or for that equation, and then this point here, 6, 180, is for the next equation. So y is now 180. A times 6 squared plus b times 6 plus 180. So I'm subbing in for x and for y from this above equation here. 0 is equal to 9a plus 3b plus 180. Subtract 180 both sides. Minus 180 is equal to 9a plus 3b. 180 is equal to 36a plus 6b plus 180. Subtract the 180 both sides. 0 is equal to 36a plus 6b. Okay, now to make these easier, I could divide this equation by 6, which would leave me with 6a plus b. And I could divide this equation by 3, simply just to make it easier. And you absolutely don't have to. You could do these equations without it. Minus 60 is equal to 3a plus b. And now I do simultaneous equations. 6a plus b is equal to 0. 3a plus b is equal to minus 60. Okay, I can rearrange this so that they're on different sides, or rewrite it rather. Okay, same with the 0. I'm going to multiply this by minus 1. So 6a plus b equals 0 is not going to change. Minus 3a minus b is equal to minus 1 by minus 60 is 60. And I add downways. 6 minus 3a is 3a. b minus b is 0. 0 plus 60 is 60. Divide both sides by 3. A is equal to 20. And then I can sub into either of them. 6a plus b is equal to 0. 6 times 20 plus b is equal to 0. 6 times 20 is 120 plus b is equal to 0. Subtract 120 both sides, and I get that b is equal to minus 120. Okay, and that's your flash revision of functions and graphs more. This doesn't go through function language as such.